For this example, we are just going to do letter A to see how we can use this idea of path difference in order to figure out what the frequency or wavelength of waves happen to be. In order to accomplish B, we can do it. Absolutely we can. But the math gets a little icky until we start to learn the relationship between the difference of these two things and how high up it happens to be. That's our next step, so I kind of want to save B for then. So let's just focus on A. We'll be able to solve it this way with path difference, and we'll be able to solve it the next way once we learn our equation that relates the difference between the two sources, the distance between the two, and how far we happen to be. So let's begin. Here I have drawn both paths that the waves will take in order to reach the car at this position. Note that the blue path is visibly longer than the red path. There obviously has to be a path difference. Also note that in this position, it mentions to us that it reaches the second maximum at this point. And so if it happens to be a maximum, something that we know is that there has to be constructive interference here. If there's constructive interference here, then we note this by saying that these two waves have to be in phase with one another. We also know that both of these are antennas that are simultaneously transmitting identical signals of the same wavelength. So we can see that these both also start in phase. Because they start in phase and they end in phase, then we know that in order to get a maximum right here, their path difference has to be a multiple of the wavelength. In order to reach the second maximum, we know that it has to be twice the wavelength for that. Here's what it would look like. When taking a look at the first path right here, you note that it happens to be 1,000 meters away this way, and then it happens to be only 250 meters this way. I know it's 250 because it says that this full distance is 400, and I know that these are separated by 300 and this is the midpoint, so it's only 150 here. So if this is 150, this has to be the remaining 250. So if it's 1,000 here and 250 here, I end up with a path length of 1,030.77 meters. Just by doing the Pythagorean theorem. If I take a look at the second path, and I want to see how long that path happens to be, I find 1,141.27 meters. Again, I know that my vertical right here, my horizontal obviously is still 1,000 meters away, but I know my vertical right here is not only 400 meters, but also this other 150 to make up the other point right here. And so if that's 550 meters and this is 1,000 meters, I get my path to be 1,141 meters, 0.27. So now that I have my two paths, I can go ahead and figure out what the path difference is. The difference between these two paths happened to be 110.5 meters. But they had mentioned that this was the second maximum. So my path difference has to be a multiple of the wavelength. So my path difference has to be equal to twice the wavelength. Again, I know that it has to be a whole number multiple of the wavelength because I end up with it being in phase to begin with and in phase to end with. So my starting condition is in phase, my ending condition is in phase, and so I know it has to be a multiple of the wavelength. Now I know that that multiple happens to be 2 because this is the second maximum. If it was at the first maximum, it would be at a lesser amount over here, and that would have been a number 1. So this is the number 2. If it was at the third maximum, this would be the number 3, and so on and so on. So I end up with a grand total answer of the wavelength is 55.25 meters. However, this is not what the question was asking. It was asking with what frequency was the signal. So I have to go back to my knowledge of V is equal to F lambda. And because I know what the wavelength is, and I know that the velocity is going to be the speed of electromagnetic waves, I can see 3 times 10 to the 8th meters per second is equal to the frequency, what I'm looking for in this problem, times 55.25 meters of my wavelength. I end up with a final answer of frequency is equal to 5.43 times 10 to the 6th hertz.